we are going to discuss the meaning of derivative in mathematics, right? So, talking about the meaning of a derivative, this is exactly what it means, right? So that is the f prime. So these are just a technical name, right? So and I will explain everything step by step in some few seconds. So make sure that you watch the video to the end. And this is f prime, right? So f prime of x here, that is equal to the limit as h approaches zero of this thing here, right? I believe some of you are familiar with this thing, but what is the meaning behind is the most important thing. So what I mean by that, if you have, let's say you watching me right now, this is your image, right? So a very nice beautiful image here, and then your name is behind this image. Is that okay? So your name is going to be behind this image. So maybe I wish I can call you to come and put your name in this bracket here, right? So now, if someone calls you by your name, you must respond, right? So that is the simple analogy here. So now, what is the meaning behind this definition, right? So the meaning behind this definition is that how something changes, right? So some what I mean by something changes is that maybe today you see the price of one item, maybe suppose this is a marker here, and then tomorrow the price will change, right? So that is what it means. So this is the change that will happen to any, or let's say any item that you can think of, right? So a change. So let's say you get to let's say an electronic shop, right? So maybe you want to buy a phone. So let's assume that for the meantime. So let's say you get to an electronic shop, you want to buy a phone here. So the price of the phone, maybe let's divide the year into three quarters. So maybe so let's have our first quarter here, right? So the first quarter here, and then maybe the second quarter, right? And then maybe the third quarter, right? So in the first quarter of the year, maybe that price, you know that the price of that phone, assuming that should be $50, so just an assumption. So in the next quarter, it goes to maybe $55, right? Then followed by, let's say, $60 for sure, right? So this thing is changing by what? A difference of what? Five, right? Can you see? So from here to here is a five here, and then from here to here is also another what? $5. So this change is what we are calling what? The derivative, right? How the thing is changing with respect to time. Is that okay? So over time, what happens? Now, how can you find the changes of this thing in some years to come? Any point that we want to find ourselves, provided that we are given something that we call a function. So I was give some function here for us to understand perfectly how to apply that. So what it means is that that's the whole idea behind what the derivative. So the derivative of a function here is how that thing is changing over time, right? So here, the meaning of the limit here is to show a prediction, right? So we have a simple meaning of this guy here that tells me to show a prediction. So assuming that something will happen, I have a complete video on a limit, so you may consider checking that in the comment section or the description down below, right? So now what will happen? Let's use this function to demonstrate the idea behind this definition of a changing, how something is changing over time. So now let's say we have a function. So this is the function, right? That is equal to 2x, right? So meaning that let's say this function here is if you want to buy any item that you can think of, right? So once you have the values of the item, or maybe let's change this function to let's say x square, right? So x square. Now changing the function to x square, right? So meaning that this function here is equal to x square. So maybe you get to the phone shop, of course. You get to a phone shop, and then this x here gives us the price of the phone, right? So this x here, assuming the x is the price of any item that you want to buy. Now, if the price of that item is, let's say, some $5 here, right? Right. So for sure, this is a lay down procedure, the formula of that company or the organization that anything that you pick here, you are going to square that. That gives us your price. Right. That's very, so if you plug in five here, in this case, we are going to have five squares. So the answer here is going to be 25, right? So meaning that anything that particular item is $5. So meaning that you have to pay $25 on that that item, right? So now what will happen in this, suppose this is the first quarter, right? So this is the first quarter. What will happen in the second quarter of the year, or maybe the third quarter of the year, right? So what will be the changes? So that is one thing the derivative here help us to determine the change that will happen in the near future, right? So let's use this definition to demonstrate how we can find the change that will happen to this price of structure of that organization. So the way of solving this thing is that we are just going to plug in, right? So once we plug in, what I mean by that, we are giving the f of x here, the function, to be x squared. So this is what we are having here. So we are left with this, right? So what about f of what, s plus h here, right? So this h here, I'll explain this thing in just some few seconds, right? So this h here means that we are going to add a to the price here, right? So we are going to add it. So this is what I'm trying to say here. So initially the price was of $5, right? So let's say add 8 to this 8 can be anything that you can think of. Maybe let's say there's the $2 in addition, there's a $3, there's a $4, and so on and so forth, right? But according to this definition here, we are calling that 8 to be 0. Is that okay? Now, remember, we cannot divide by 0. So everything is being divided by 0. We cannot divide by 0 in this sequence, which doesn't happen in mathematics. So let's hold on for some few seconds. So here we are going to add h to this x here. So meaning that we are going to have x plus h here, everything square, right? So remember, we are squaring everything here, right? So squaring the x here square. So we are just adding some amount to the initial amount here. So here we are going to have, if you don't know how to do this, make sure that you check our playlist on how to expand this, whichever way you want to go. Now that one is your own choice, right? So here I have x squared, this guy multiplied by this one, that should be your positive of 2x, and then h, and then finally you square this one, that gives us h square, right? So this is just a simple method that I'm using. Now this is what we are having. Once we have this, according to the definition here, we need this thing here, and then as well as we need this function, then we are free to go. Is that okay? Now let's move on. So from this definition here, we are just going to replace. So we have this thing at our disposal here, right? And then we have this one last way. So meaning that this guy here is going to be the limit as h goes to 0 of what this guy is on. Exactly what is happening here. So we have x squared plus 2sh, right? And then plus what, h squared minus what is happening, this guy, right? So the f of s is the function, the real function given to us, x squared, and then everything divided by h, right? So the question is, how can we proceed from here? Because here we are going to find the limit. As I said earlier on, the limit is a prediction. So can we predict something that we haven't seen at what point zero, right? So at the point zero, remember, if you plug in the values of the x, the h, which is 0 here, into this function, it's very impossible for us to divide everything here by 0, right? So how can we manipulate this guy? Now, at this point, you need to have the idea on how to solve a limit, right? So remember, we cannot divide by 0 here, right? So you have to do something for us to take this guy, this stubborn guy here away. So right here from the top here, you can see that, okay, let's group first, right? So grouping, we have the limit as our h here is going to 0. Remember, I promised to explain this thing right in just a few seconds. So we can group the top one. We have the x squared here, and then there's another x squared here. So x square minus x square here plus 2sh, and then plus h square, and then these two people vanish, right? So everything divided by 8. Of course, that is going to be the limit as h is going to 0, right? So this one goes away. So we are going to have 2sh, and then plus our h square, everything divided by h, right? So here we can manipulate this thing and make sure that we are dividing each of the 10 by the h. So this is going to be the limit as our h is going to 0, and then the 2xh divided by h here, right? And then plus h squared divided by h, right? So this one can cancel this out, and then this one, then we are going to leave it for just one of the h on top here, right? Okay. Now, so after cancel out, this is what we are going to have. So here, clearly, we can plug in the values of the h here, all is equal to 0 into this function, right? So that is the most important thing or the key step here. Now look at something. What is happening? What is happening here is that, so remember at the beginning of the video I said that the derivative here is the change. So what we are looking for right now is the change, right? So here it means that here this 8 here is something that we are assuming that that change will go higher in the near future, right? So this is just an assumption, right? So maybe if the change from the initial assumption was what, just $5, so maybe we are assuming that this price here will go higher, right? So maybe, or it can come down, right? So by an assumption, the idea behind that, that it will go higher, maybe +1, right? So that can be a $6 changes, or maybe it will come down. Now, what will happen if there's no change to this $5? So it remains consistently as well the year goes along, right? So that is something that we are doing here. So this 8 year is something that we are assuming that the price will jump, right? So the price will jump what, over the year or over time, right? So this is an assumption. So the assumption is that if there's nothing happens to what, the changes of the price over time here, then we are going to have this guy is going to be equal to, by plugging in the values of the zero. So you have the 2x plus 0, that is equal to just a 2x. So the change remains as it is, right? So this change remains as it, there's no what, any increment. Is that okay? So this is just an assumption. So once this 8 here is going to 0, this is just an assumption that maybe suppose the price or the change of the item goes or increase in the near future, what will happen? Right? So the assumption, what we are assuming here is that what will happen if nothing, there's no increment in the change. So this 2x here is a change that will happen to the price of the what, any item that you can think of relating to the initial function, right? Okay, so perfect. Now if here we are having, maybe let's say the price was just like let's say $15 here, right? So the change that will happen to this thing is going to be 2 multiplied by 15. So that change is going to be 30, right? So the change consistently is going to be 30 over time, and so on and so forth, provided that you know the values of the x in this case, right? So perfect. If you get some value from this video, don't forget to give us a thumbs up, subscribe to the channel, comment down below on anything that you want to see more relating to a derivative. You have a more on what this particular topic, so make sure that you check the playlist down below.
Are you a high school math guru? Do you belong to a high school math club? Or do you know someone special in high school you want to express your gratitude? What about showing appreciation or encouragement to a friend or relative in a form of a gift? Will you soon graduate from high school, then congratulations in advance? What if you guys are in uniform? Great, right? You may check our store in the description below for nice shirts and more. We love you.